Hey everybody, this is Larry. This is day 5 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about today's farm. And yes, I did get a haircut. Thanks for noticing for the two of you. Today's farm is global and local inversions. And keep in mind that I usually start these live, so if it's a little bit slow, just fast forward or watch it in a faster speed or whatever. So okay, so you have some permutations. What are we trying to do? Okay, the number of global inversion is just okay that. And local inversion is easy. It seems like it's just next to it. Okay. So we try to figure out whether this seems like it's easier, maybe. It wants you to return true if and only if the number of global inversion is equal to the number of local inversions. So the thing is that, the number of local inversions, this is the first thing I noticed, is that the number of local inversions will always be equal to or bigger than the number of global inversion. So in this problem, the only thing we have to do is try to find an example of one case where I don't know why this time limit have to be reduced, but because from my guess is that, and this is maybe a little bit greedy, is that we just have to find one instant in which there's a global inversion that is not local, and then you're done. Because is it even more than that? Is it even? Yeah, I mean, and what I was also going to say is that if the two local inversions, then that's already done. Because if there are two local inversions, let's say you have 3, 2, 1, that's two local inversions, but you can also say there's an extra global inversion in which the 3 is bigger than 1, right? So there's actually only a very limited case, because now there's two local and an additional 3 bigger than 1 for 3 global, right? So that means that is always not true. So we could even simplify it or narrow down the problem a little bit further in that there's only one local inversion has to be in the answer. So as long as there's 2 local inversion, we're done. And that could be done with a for loop. And then my other question is, can there be 2 global inversion without 2 local inversions, right? Because then that would be really easy. And I don't think so. Well, yeah, because one thing to also notice is that every number is unique because it's a permutation of O to n minus 1. So because they're unique, there's some pigeonhole thing there where, let's say there's something like, no, that's not true. Okay, so I think this is a case where there's 1 local, but there's 2 global. Okay. So then from then, we just have to, I think it's sufficient to do some sort of greedy in one, but I mean, it would have been, there are a couple of ways you can do it, but you need other things. One is just see if there's, if there are 2 local inversions, then you're done, because the 2 local inversions implies at least 3 global inversions. But in the case of 1 local inversion, just to figure out this case, is a little bit of a suffix minimum. Because for here, I'm asking, is there inversion that's at least 2 steps away, right? What's another possibility? Or let's just say, let's say this is maybe something like that. I'm just right now. I'm just trying to think about the counter cases in my head, and what my statement was. And sometimes proofs are hard, and what I do is try to as much as I can exhaustively come up with all the cases in which that may be counter cases, and almost like a proof by exhaustion, if you will. And here I'm trying to think if this statement is correct, where this problem reduces to, is there an inversion of length of at least 2, right? Because in this case, there's an inversion of length of at least 2. And let's say this is 5 for now. There's an inversion of length case of at least 2. Well, then there no, because then we can have this in which there's only one local inversion. No, that's still good. Well, so this has a length of 2. So then there's 2 possibilities, right? One is that this number is smaller than 4, which is a 1, say. Then that means that there's 2 locals as well. Or rather, there's 1 local, but 2 global, right? At least 2 global. And then the other case is if this is a 3, which I guess we ignore this for now. Well, then obviously there's already, what we said earlier. And then the other case is if this is a 5, those are the 3 possibilities, right? It's smaller than both numbers, it's in the middle between 2 numbers, and then the bigger than 2 numbers. And there's also 2 global, right? Because they both use this number. So if any number that's bigger than 2, there's at least 2 global. And if there's a number that's between them, well, there's already, this one adds 1, and it doesn't matter what this is, because if this is smaller, this adds an additional 1 that is not a local. There's one is the local. It's what this gives you some sort of local inversion, and then this gives you an additional 1. So I think that is a good enough answer. So then here we can just use the suffix min for that reason. Again, if this video the flow is a little bit weird to you, I am trying to go through my thought process as I solve for a problem, as I would during a contest or something like that, or maybe even an interview. So I hope that this is useful, even if it's a little bit awkward and it's not explanation-y, because sometimes for me, like I said, for these sort of problems, maybe it's a little greedy. I don't know if this counts as greedy, but me try to figure out the property of these numbers and how it could fit together. Sometimes I just do exhaustive search, manual search of like all the scenarios and how to break them up. So hopefully that makes sense. So then now we can go n is equal to length of a for index in range sub, let's just say n minus 1. We go to 0, which is very awkward in Python looking, but okay. So then let's just say min is equal to infinity for now. I just choose a big number, it should be okay. And then we go for it 1 by 1. If index is greater than min, we return true, right? Otherwise we return false. Oh, sorry, which way does it go? If it's okay, so this is return false. Otherwise, we may return true. We might have to double check on this for 1 versus no, because we definitely know that this is true. What happens if it is not? That means that if there's no, that should be. I think the contrapositive. This is essentially the contrapositive of what we supposed to. I think that should be okay. If index plus 2 is less than n, we do min is equal to min of the current min and a of index plus 2. Actually, I guess we do this first. That was kind of a useless taste. And as we said, something like 4, 1, 2, 3, 4, 5, say, and And in this case, the answer should be yes. Well, actually, I think this would give me a yes, but I think this is a wrong answer. So I think I might have to adjust it a little bit. Because there's one local. Oh, and then two global. No, should be right still. And then what we said about having this as one, and then let's just say no, this kind of okay. Oh, whoops! I forget the zeros always, and we can fix that just by adding 0. Oops. Because that should not change the result. Okay, wow, that is not great. So this is the third answer. This is I return true because 1 is greater than 0, but there's only one local one. There's one local one and 2 global ones, right? Oh yeah. So that's That's just an implementation error, I guess. Do I have an off by 1 somewhere? I guess so. If this is 0, this should look at 2, and then yeah. Oh, whoops! Wow, how did this even pass anything? What I meant is this, of course. Lately, my mind has just been a little bit off. Like I'm saying the right things, but even then, okay. So this is what I expect. It's a little bit awkward because I feel like, I mean, I've been doing this in contests too, so it's a little bit discerning. But okay, so this looks okay. Let's give it a submit. To be honest, I'm maybe 60% confident before I look at the results. But you know, let's take a look. Oh, cool. Because for me, greedy problems are like that, in that like I just have a higher degree of uncertainty, so I'm not sure. So this is actually a kind of a cute problem as a result. But you know, hopefully, you know, if you watch other videos, they may just tell you the answer. But hopefully, me, you know, taking the time to actually go through my thought process as I would solve them. I mean, obviously, if I was in a contest, I might be much faster. But I'm trying to explain it or have a way to articulate it. So hopefully this is a little bit more useful. I mean, I don't think I have to go over the complexity too much. This is linear because of the for loop and just checks, and constant space because we just have like a couple of variables. Yeah, that's all I have. Let's look at the hints. I want to see if where can 0 be placed in the ideal permutation? What about the 1? Maybe there's another way of represent this, but I think maybe that's, you know, like I think probably we're expressing the same thing. I don't know why the time limit has to be reduced. I guess n squared kind of works for this one if you're in Java or something. But yeah, let me know what you think. Hit the like button, hit the subscribe, and join me in Discord. Hope y'all have a great rest of the week. Yeah. Take care of yourself, take care of others to good health and to good mental health. I'll see you tomorrow. Bye-bye.